What we have been doing up to now, we have been developing object diagrams. One object diagram for the ER schema, one object diagram for the ER state, one object diagram for the relational database schema, one object diagram for the relational database state. This is the representation. This is a formal object diagram. So this is a formal object diagram which brings these four excerpt object diagrams together. This is the ER representation for the ER schema. For example, you see the person entity. This is the representation of the relational database schema. For example, you see here the marriage relation. This is the entity relationship database state. For example, you see here the representation that an instance object that represents Charles. And this is a representation of the relational database state. And you see here one tuple representing Charles, one tuple representing Diana, and one tuple representing the marriage. And for example, the tuple representing the marriage has 1, 2, 3 attribute maps that give values to the husband attribute, that give values to the wife attribute, the attribute map, the 3 attribute map objects of the marriage tuple give a value to the husband passport, to the wife passport, and to the date attribute. And these are the 3 attributes of the marriage relation in the relational database schema. In addition, and so you have the connection here in the syntax part, the links in the syntax part. You have the connections inside the semantics part, inside the state part, and you also have the typing links that go from the state part into the schema part. So for example, you have a typing link, you have a value object 1, 2, 3 integer underscore 1, 2, 3. That's a value object which represents the integer value 1, 2, 3. And this, and in formal terms, the typing that this value object is an integer value is reflected here by this link. That is, it is connected to the integer data type. Or you have the connection that you have here the representation for Charles. It's an instance object representing Charles, and this object is typed as an entity, and that's this link which types instance as an entity. Or we will have the link, exactly here we have the link, that's the marriage link in the ER state, and this is typed by the relship object, namely by the marriage in the ER schema, this link here. So this is an object diagram. We need a class diagram for the object diagram. And you see here, this has been formally done in use. It's really not so trivial object diagram in use. We need a class diagram for it. In formal terms, the use class diagram is over here. We have here the ER schema object, we have the entity class, we have the relship class, we have the relent class. We have here the relational database schema. The relational database schema is connected to many relational schemas. Each relational schema has many attributes. As an entity can have many attributes. A relationship belongs to the ER schema object. A relationship has two or more relationship ends. A relationship end is typed by exactly one entity over here. The attribute name is inherited from a general class here to the respective objects, to the respective classes over here. And here in the syntax part, you have the data type, and you see you have the data type class, and you see here that an attribute is typed by exactly one data type. So the multiplicities and the links also reflect an important part of the representation that we need in the object diagram. I will not go into the details here of the state part, of the ER state part, and of the relational database state part. What is interesting here is that in addition to having the schemas and to having the states, we also have a transformation object or a transformation class. A transformation is connected to a transformation. The transformation class is connected to one ER schema. A transformation is connected to one relational database schema, and these links will then represent that a particular ER schema is translated into a particular relational database schema. This is reflected here by a transformation object and by the respective links here. I will not go into the details here of the states, that's too complicated. I have I have preferred to have a slightly different, more intuitive description here than the use class diagram. I have used here slightly different notation. I have used here composition, aggregation, and functional associations indicated with an arrow. And I will explain this right now in the following. So let's look at here. I think the black diamonds are quite intuitive here. An ER schema consists of many entities. An ER schema consists of many relships. An ER schema owns its relationship end, and an ER schema owns its attributes. An entity owns its attributes. A relational database schema owns the relational schemas, which are part of the relational database schema, and a relational schema owns its attributes. Here we have again the situation that we have three black diamonds. So, and this in this case, it indicates that an attribute object may belong to an entity. An attribute may be an entity attribute. An attribute may be a relationship attribute. An attribute may be an attribute which belongs to a relational schema. And the black diamonds on the other side of the associations for the attribute indicate that the attribute can only belong to one of entity, relship, and rel schema. An attribute cannot be at the same time be an entity attribute and a relationship attribute. An attribute exclusively belongs to an entity, and when this is the case, the attribute cannot belong to a relationship, and vice versa. So it's a good and intuitive use here of the black diamonds, of the composition part-whole relationship. Yes, and on the other hand, we see I have used here functional relationships. And functional relationships are denoted here with an arrow. A relationship end has exactly one entity, and that's the type of the relationship end. And this is indicated here with a functional relationship. And there are many functional relationships which go from the state part into the syntax part, into the schema part here. And these are these functional relationships over here. And this is shortly indicated over here. So this is a complete class diagram. And an object diagram for this class diagram, we see it over here. This is the object diagram, this is the class diagram. So our metamodeling, the two data models, its schemas, and the states of the schemas is done by developing a class diagram and a concrete metamodel instantiation is given by a complex object diagram. In the following two slides, I have represented with two object diagrams some circumstances that one would like to that one could represent in connection with this Diana Charles example. So when we take the simple sentence here, Diana moves from Wembley to Windsor. And this sentence here is represented by this object diagram. The object diagram has a schema part. This is an ER schema. And the object diagram has a state part, and this is the state part over here. So in the schema part, we have an ER schema, which has one entity. The entity has two attributes, namely an attribute name and an attribute address. The name is a key attribute and the address is a non-key attribute, and both are strings. So you could take these objects here and represent them in form of an entity, of an ER diagram, in form of an ER diagram. You will not have any relationships. You will only have one entity over here. Now the state part says Diana moved from Wembley to Windsor. So what is done over here? We have two ER states. That's ER state 1, that's ER state 2. In both ER states, an instance is present, namely the instance Diana. In both ER states, there are there is an attribute assignment, an attribute map for the name attribute. In both states, this instance has the name attribute. For this instance, the name attribute is Diana. So this attribute map is valid in ER state 1 and ER state 2. What is different in ER state 1 and ER state 2 are the attribute maps. So here are two attribute maps, two attribute assignments. For these two attribute assignments are attribute assignments for the address attribute. And these are different. So this attribute assignment is only valid in ER state 1, and this attribute assignment is only valid in ER state 2. And in ER state 1, the address is Wembley, and in ER state 2, the address is Windsor. So in this sense, this schema, these schema objects and these two state objects represent the circumstances Diana moves from Wembley to Windsor. I have a second, quite similar situation. I have the same schema object here, person with key attribute name and non-key attribute address. And I have here again, I have two ER states, ER state 1, ER state 2. And what is shared between these two ER states is the instance object. The instance object is present in ER state 1 and the instance object is present in ER state 2. And what is reflected here in this situation, in this object diagram, Diana moves and marries. So originally we have one instance here, one object, which is present in ER state 1 and present in ER state 2. And this instance, the name of this instance was Diana Spencer in ER state 1, and she lived in Wembley in ER state 1. And in the next state, the instance is still present, but she is called differently. She's called now Diana Mountbatten Windsor, which was the civil name of Diana. And now she's living in Windsor. So the object is still present, the instance is still present in both states, but all attributes have changed. The name has changed and the address have changed. The name is different and the address is different. So in this sense, this object diagram represents what is described here in the sentence. Diana moves and marries, changes her address and changes her name. This is these two examples are the main motivation that an ER schema can be associated with many ER states. So one ER schema, over the time, this ER state changes, and therefore one ER schema can be associated with many ER states. So yeah, there are the change of state is represented here by having the option of having many ER state objects. Okay, these were these two kinds of sentences that I was playing around with Diana. I shortly want to give you the feeling about what is present here in the respective parts of the class diagram. So everything is gray here, and now something comes into the foreground. The left upper part represents the entity relationship syntax. We have the ER schema, we have the entities, the relationships, the relationship ends, and the attributes and the data types. We have the ER semantics. The ER states are typed as through the ER schemas. The instances are typed through the entities. The links are typed through the relationships, and the rel and maps are typed through the relationship ends. The attribute maps are typed through the attributes, and the values are typed through the data types. And analogously, we have the relational syntax part. In the relational syntax part, we have the relational database schema, which consists of many relational schemas. A relational database schema consists of many attributes, and each attribute is typed by a data type. And we have the relational semantics. A relational database states consists of many tuples. A tuple consists of many attribute maps, and each attribute map is typed by a functional relationship here and is given a value here, an attribute map or an attribute assignment. Please note I have used the strong form of part-whole relationship over here and over here, and I've used the weak form of part-whole relationship, namely the aggregation over here. Please remember in the example that we had before, in both examples, the instance was shared by two database states. So yeah, the instance occurs in two ER states. Diana occurred in two ER states. Diana is shared by two database states, and therefore I have this weak part-whole relationship between ER state and instance. On the other hand, an entity exclusively belongs to one ER schema, and an attribute exclusively belongs to the entity or exclusively belongs to the relationship, and the exclusiveness sits here in the strong part-whole relationship in the composition. So that was the ER semantics, that was the relational syntax, that was the relational semantics with the relational database state consisting of many tuples. And the transformation now connects a relational in ER schema and a relational database schema, and it connects the corresponding ER state with a corresponding relational database state. What is missing in our game now? So we have here now a nice class diagram, and one of the major points in this course is, of course, the use of OCL, and OCL can be used for specifying invariants and constraints invariants. That will be the topic of the next part.